Welcome to my algebra class. We're on chapter 12, section 1. We're going to be working with quadratic equations again and with perfect squares. We're going to isolate the perfect square. We're going to take the square root of both sides. When we have that happen, we get two possible answers, plus or minus the square root of whatever's under the radical. If k is a positive number, then we have two answers, one positive, one negative. If k is 0, then we only have one answer. And if k is less than 0, there's no answer since we can't take the square root of a negative number. So for the first example here, since m squared is isolated, that's a perfect square, we take the square root of both sides. So m equals plus or minus the square root of 49. So m, since 49 is positive, we have two answers, positive 7 and negative 7 both work. I put them in, 7 squared is 49 and negative 7 squared is 49. Problem number 2, we first have to isolate the perfect square, so we divide by 5 and we get r squared equals 9. Take the square root of both sides, so r equals plus or minus the square root of 9, so we have plus or minus 3. Example number 3, the perfect square is isolated. We take the square root of both sides. We get x plus 6 equals plus or minus the square root of 64. So x plus 6 equals plus or minus 8. So we subtract 6 from both sides. We get x equals negative 6 plus or minus 8. So there are two answers, negative 6 plus 8, which would give me 2, and negative 6 minus 8, which would give me negative 14. And we could check that negative 14 plus 6 is negative 8 squared, works, and 2 plus 6 works. So there are two possible solutions. Number 6 doesn't have its 7 there. There we go. Okay, we're going to fix that. Number 4, we first have to isolate the perfect square, so we divide by 5, and we get x minus 4 quantity squared equals 8. We take the square root of both sides. We get x minus 4 equals plus or minus the square root of 8. So x minus 4 equals plus or minus perfect square, and there is 4 times 2, so we take that out, 2 radical 2. Add 4 to both sides, we get x equals 4 plus or minus 2 radical 2. And unless they say to approximate, we'll leave the answer as that. Number 5, this is a perfect square trinomial. It's y plus 3 quantity squared. The two ends are perfect squares, so I take the square roots of them, and I check the middle, 3y, and 3y makes 6y, so it's y plus 3 quantity squared equals 49. So I take the square root of both sides. I get y plus 3 equals plus or minus the square root of 49. So y plus 3 equals plus or minus 7. So y, subtract 3 from both sides, equals negative 3 plus or minus 7. Negative 3 plus 7 is 4, and negative 3 minus 7 is negative 10. And if you put those back in, they'll both give you 7s, and squaring them will work. And the last example, we have to isolate the perfect square, so we subtract 15 first. So we get 2 times 3x minus 5 quantity squared equals negative 8. Divide by 2, and we get 3x minus 5 quantity squared equals negative 4. And then we take the square root of both sides, and we get 3x minus 4 equals plus or minus the square root of negative 4, but that's impossible. We don't have a solution for that, so we say no solution. That concludes the explanation. You need your book open to 563, and we're doing 1 through 39. It says express irrational solutions in simplest radical form. If the equation has no solution, write no solution. So problem number 2. We have the quantity y minus 7 squared equals 0. Perfect square is isolated, so we get y minus 7 equals plus or minus 0. So y equals, adding 7 to both sides, 7. There's only one solution. Remember what was under the radical? If it's 0, we only have one solution. Number 4, a squared equals negative 9. We take the square root of both sides. We're taking the square root of a negative number, so there's no solution. Problem number 6, we have 6t squared equals 156. Isolate the perfect square, so we divide by 6. And we get t squared equals 26. Take the square root of both sides, so t equals plus or minus the square root of 26. And there are no perfect squares in that, so that's our answer. Remember that plus or minus means there's two answers, one positive, one negative. Number 8, we have x squared minus 48 equals 0. Isolate the perfect square, so we add 48 to both sides, so it's x squared equals 48. Take the square root. We get x squared equals plus or minus the square root of 48. There is a perfect square, and 48 is 16 times 3, so x equals plus or minus 4 radical 3, taking out the square root of 16. Problem number 10, m squared minus 54 equals 0. We're going to add 54 to both sides, so that gives us m squared equals 54. Take the square root of both sides, so m equals plus or minus the square root of 54. There's a perfect square in 54, it's 9. So we take it out, so it's going to be plus or minus the square root of 3 radical 6. Problem number 12, we have 7m squared minus 42 equals 0. Isolate the perfect square, add 42 to both sides, so we get 7m squared equals 42. Divide by 7, and we get m squared equals 6. Take the square root of both sides, m equals plus or minus the square root of 6, and there are no perfect squares in 6. 14, we have 4r squared minus 7 equals 29. Add 7 to both sides to get the perfect square by itself. We get 4r squared equals 36. Divide by 4, and r squared equals 9. Take the square root of both sides. R equals plus or minus the square root of 9, which is plus or minus 3. Positive or negative 3 work. Problem 16, we have the quantity x plus 6 squared equals 16. The perfect square is isolated, so take the square root of both sides. So we get x plus 6 equals plus or minus 4. Square root of 16 is 4. So x equals, subtract 6 from both sides, negative 6 plus 4, negative 6 minus 4. Plus 4 would be negative 2, minus 4 would be negative 10. We have y plus 2 quantity squared equals 12. Take the square root of both sides. We get y plus 2 equals plus or minus 12. It has a perfect square in it, 4. 2 radical 3, simplifying it. Subtract 2 from both sides, so y equals negative 2 plus or minus 2 radical 3. Number 20, we have z minus 3 quantity squared equals 32. Take the square root of both sides. We get z minus 3 equals plus or minus the square root of 32. There's a perfect square in 32. It's 16 times 2. So that's z minus 3 equals plus or minus the square root of 4 radical 2. Add 3 to both sides. Z equals 3 plus or minus 4 radical 2. We have 6 times the quantity z plus 5 squared equals 42. Isolate the perfect square, divide by 6. We have z plus 5 quantity squared equals 7. Take the square root of both sides. We have z plus 5 equals the plus or minus square root of 7. Subtract 5. So to isolate z equals negative 5 plus or minus the square root of 7. In the next section, 26, we have a trinomial x squared minus 14x plus 49. We need to see if it's a perfect square trinomial. The ends are perfect squares, so the square root of x squared is x. Square root of 49 is 7. And if I times these together, I get 7x, and double it, I get 14. So it's a negative x minus negative 7 minus 7 quantity squared equals 64. Take the square root of both sides. So we get x minus 7 equals plus or minus 8. So x adds 7 plus 8 and minus 8. 7 plus 8 is 15. And 7 minus 8 is negative 1. So our solutions are 15 and negative 1. 28, we have y squared minus 18y plus 81 equals 144. Check to see if it's a perfect square trinomial. The square root of y squared is y. 81 is a perfect square, it's 9. That's 9y, in the middle is twice that, so it is a perfect square trinomial. So we could rewrite it as y minus 2 quantity squared. Take the square root of both sides, we get y minus 9 equals the square root of 144 is 12, plus or minus 12. Add 9, so we get 9 plus or minus 12. 9 plus 12 is 21, and 9 minus 12 is negative 3. So that's our solution. Problem number 30, we have 1/4 t squared minus 9/64 equals 0. Isolate the perfect square, so we're going to add 9/64 to both sides first. So we get 1/4 t squared equals 9/64. Multiply by 4. To get rid of the 1/4, we get t squared equals 9 over 16. Take the square root of both sides, so we get t equals plus or minus the square root of 9/16, which is 3/4. Square root of 9 is 3, the square root of 16 is 4. Problem 32, 1/6 x squared minus 4 equals 5/6. We could multiply by 6 and get rid of the denominators. So this is x squared minus 24 equals 5. Add 24 to both sides, so we get x squared equals 29. Take the square root, so x equals plus or minus the square root of 29. We have 0.49 x squared plus 2 equals 3.96. I'm going to multiply by 100, so I get 49 x squared plus 200 equals 396. Subtracting 200 from both sides, I get 49x squared equals 196. Divide by 49, I get x squared equals 4. Take the square root of both sides, x equals plus or minus 2. Problem 36, I have 5 times the quantity t plus 2 squared equals 3/5. We can multiply by we can divide by 5. That's not going to be a problem. So we now have t plus 2 quantity squared equals 3/25. Take the square root of both sides. We get t plus 2 equals the square root of 3 over 5. Plus or minus the square root of 3 over 5. So t equals, subtract 2, -2 plus or minus the square root of 3 over 5. And if I want the same denominator, and they do prefer that you write it as one fraction, that's -2 or 1, so the least common denominator would be 5. And 1 goes into 5 times, so that's -10 plus or minus the square root of 3 over 5. So our final answer as one fraction is -10 plus or minus the square root of 3 over 5. So be careful on these kind here. If you come up with a fraction as your plus or minus, you have to change it into one fraction. And number 38, we have y minus 3/7 quantity squared equals -8/9. And we can see right away, if I take the square root of both sides, I can't take the square root of a negative number, so no solution. And that concludes the evens. Be sure you check the back of the book for the answers to the odds.